Now let us move on to the second question from the AP Calculus BC, free response for the 2017. The figure above shows polar curves. Aren't polar curves exciting? R is equal to f of theta is 1 plus sine of theta cosine of 2 theta, and you also got g of theta 2 times cosine of theta from 0 to pi over 2. Let R be the region in the first quadrant bounded by the curve r equals to f of theta, so this must be f of theta, and the x-axis. So we have our region R, and let S be the region. Let S be the region in the first quadrant bounded by the function r equals to f of theta, r equals to g of theta, so the one above, I'm guessing it's g of theta. I mean, it has to be g of theta, and the x-axis. So S of theta is going like this. So we got green one and the blue one. Intriguing. What's going to happen now? Find the area of R, like that. Okay, how do we find the area of a polar curve? You should have this memorized. 1/2 from the initial angle to the terminal angle of the r of theta squared d theta. If you wonder where this is coming from, you know the area of a sector. Maybe you know the area of sector is equal to 1/2 r squared theta from pre-calculus. And as you're adding up this with differential angle from the initial angle to the final angle, you obtain the integral given above. Now all we have to do is apply this to R, and R is bounded by f of theta and the x-axis. So that's gonna get us what? Area is going to be 1/2. You're going from 0 to pi over 2 of r of theta, which is 1 plus sine of theta cosine of 2 theta, and you want to square this. D theta, plugging this into your calculator, gets you, make sure it's in radian mode, by the way. That should get you 0.648. Now let's move on to part B. I guess you can always put square units, just in case. Part B, the ray theta is equal to k. So what is that? Well, if it is theta is equal to 30 degrees, which is 30 degrees like this, the ray is going to be pointing like this. So ray theta is equal to k. So we got some angle k. So we got some angle k, and you have a ray going on. Where 0 to pi over 2, k is in between 0 and pi over 2, divides S into regions of equal area. So you have this ray going on, and you know this area to the left and this area to the right are the same. Okay? Right, but do not solve n. Oh man, I did not copy the entire question. It should be the integral or integrals that can be used to find k. That was the question. I am sorry for cutting it apart. So how can we find this? We know, what do we know? We know as we're going from 0 radians, all the way to k radians, you should get some area, some red area below. And as you're going from k all the way to pi over 2, you should get another area that should be the same. So how can we write this out? How do we write this out? Well, that's not too bad. We have the area from 0 to k. So 1/2 from 0 to k of what's our function now? Our function is we have g of theta squared to get the area of this thing, the black thing I'm sketching now. So that's going to be g of theta squared. And we want to subtract it. We want to subtract it from the let's make it purple. The purple area given by the f of theta. So we want to subtract it. By f of theta squared with d theta. So that's the first equation, and you need to plug in the respective values. So for g of theta, you want to plug in 2 cosine of theta. F of theta, you should plug in 1 plus sine of theta cosine of 2 theta. And we want this expression to be equal to 1/2 Now we're going from k to pi over 2, k to pi over 2 of the same expression. I'll actually write it out this time. You should write it out for both of them in the actual test. 1 plus sine of theta cosine of 2 theta squared d theta. So that's the answer to part B. Now let's look at part C. For what does it say? Let's use an eraser. Oh, that's erasing the entire thing. What does it say? For something theta, between 0 and pi over 2, let w of theta be the distance between the points with the coordinates f of theta theta and g of theta theta. Find the expression for w of theta. Well, as you can see, g of theta is extending out farther than the f of theta for every point in between 0 and pi over 2. So what's going on? If you pick some theta between 0 and pi over 2, you got some f of theta, which is this distance, and you got some g of theta, which is the distance all the way. So distance in between these two is simply going to be g of theta minus f of theta. That's going to be w of theta. And we wish to find, and you should plug in the respective functions for each of them. Find w of theta, the average value of w of theta, over the interval from 0 to pi over 2. Well, that's just the definition. That's just the definition of the average value. 1 over the interval, pi over 2 minus 0, and 1 over the interval times the definite integral over the interval. So 0 to pi over 2 of g of theta minus f of theta d theta. And you should plug in the respective function again. And plugging this into your calculator should get you, what do you get? I have it written out. That should get you 0.485 units, if you want to specify. D, using the information from part C, find the value of theta from which w of theta is equal to w of a. So we know w of a is 0.485, and you want this to be equal to g of theta minus f of theta, which is w of theta. So just write this down, plugging in respective function, and using what? Using your calculator to numeric solver. For TI-84, I recommend going into click math, and then clicking B, and that should get you a numeric solver where you can plug in the left side of equation, set it equal to the right side of equation with some variable, and they're gonna tell you what the variable is. And make sure for the guess you plug in something like 1, something in between 0 and pi over 2, and you should get a value. Let's erase this. You should get a value of what do you get? You should get a value of 0.518 radians. But we're not done. Is the function w of theta increasing or decreasing at the value of theta? Well, to find it, all we have to do is find, what was it, w of theta? Yes, we want to find if w prime of theta is positive or negative. If it's positive, it's increasing. If it's negative, it's decreasing. So how can we find it? W of theta is what? Was it f or g? G. So g of theta minus f of theta. And make sure you plug in the respective function once again. So, and we wish to find w prime at 0.518. And that's just going to equal to derivative with respect to theta of our g of theta minus f of theta at our data value of 0.518, and you can plug this into your calculator, and that should get you negative 0.580, which is less than 0. And so what do we know? Since w prime at 0.518 is less than 0, w of theta is decreasing at theta is equal to 0.518, and we are done.